Hello, today we are going to learn function of random variables, chapter 6, and the topics are distribution of functions. We are given a random variable x. We have to find a function of random variable x, how its distribution looks like, and we are going to find expectation of function, reliability of system, etc. At first we will look at a linear function ax plus b. So this is the function, and we will like to see how the probability distribution of g looks like given that x function of probability density function of x is given. So let's start with CDF. This is just the derivation for CDF of y. For example, this is y, so fy will look like this one. We can write down probability of y less than or equal to y, and then y will be replaced by ax plus b here from here. So, and we can rewrite this like this: x is less than y minus b. You can see we can transfer the b to the right side and rewrite the expression like this. So what is this? This is another probability for random variable x. Okay, so now we will write it down in terms of fx. So because x is less than or equal to something, so that is what we express in terms of CDF fx. So we draw some conclusion that if y is a linear function of x, then fy can be rewritten as the function of CDF of x, which is like this. But here we, instead of using a value of x, we have to use this notation y minus b divided by a. So so here we can see that we are not using the value of y. Instead we are using y minus b divided by a. So note that. So if we find we already find out what is the CDF, we can just differentiate the CDF and find the PDF. So this is the expression of PDF. We just differentiate it. So if we want to differentiate, because this is a function, we can use this rule fxu by du by y, where u is the inner part of this function. I think all of you done mathematics differentiation like using this formula. So now, so if you use this, if you differentiate fx, you will get small fx, which is PDF of x, and if you differentiate u, where u is this part, then you will get this one, because u is nothing but y minus b, and u by dy is 1 by a. So finally we get this one, right? Okay. So now all of this derivation, we have derived two formula here, one for CDF and one for PDF, but this derivation is only valid for if a is greater than 0. Now what will happen if a is less than 0? For a is less than 0, we will derive another two formula, something like this. So this is very close to this one, just we have to use 1 minus something, and for fy we have to just put a negative sign here. That's it. In next in next slide we are going to solve a problem using these two formula, fx and small fx. So let's find out a distribution of a random variable y, given that y is equal to 2x plus 7. Here y is a function of x. Now we are going to derive this CDF and PDF of y in terms of fx, small fx and capital Fx. So here we are not giving any particular distribution for x, we are just using the symbol. If we compare this, if you recall the previous formula, here a equal to 2 and b equal to 7. So using these values we can find fy is equal to y minus, you can remember y minus b divided by a, it was something like that. So y minus 7 by 2. So this is our new fy. And similarly, if you recall the formula of PDF, or you can just differentiate it, both are fine, but you can just use the formula directly, which was 1 by a fx in fx of y minus b divided by a. So we put the value of b and a here and we get the fy. In this example we have not used any particular value or function for distribution function of x. Now let's do an example. I will let you do the practice this example using the same function, but we are now giving a we are giving a particular distribution function for x. Okay, so what you have to do is now is you need to you are given the PDF, you have to write down the CDF also. You know from chapter 4 that CDF will be 1 minus e to the power minus lambda x, and then you can use these functions, that is lambda to the power into e to the power minus lambda x. This you can use this function here in these equations, and you can find the finally you can find the fy. But you have to use this function which is varied for x greater than 0 in here fx, in this formula. So how you are going to do that? Please try to do it yourself. Later if you have confusion or you cannot do it, please share with me in later live section. I will help. So here you just put these values. You can see the fx, right? So fx, inside the fx there is the y minus 7 and divided by 2. So this is the value of x. So what you have to do is replace this x. You can see the x here, right? Replace this x with this inner part, y minus 7 divided by 2. Just replace this one in this x. That's it, nothing else. Nothing you have to, that should be enough. So and also you have to keep this as a part of this formula, right? So and also and similarly you can also find the CDF if you replace the x in the CDF of fx, right? You have the fx, right? What is the fx? Fx will look like 1 minus e to the power minus lambda x, right? So in that formula you have to replace the x with this part, then you get the fy. Please try to do it yourself and share the result in Facebook group by picture or something. We will discuss it again if necessary. next we will consider power function. Consider the quadratic power function. For example, y equal to ax square, and it is valid for a greater than 0. So for this function we will try to derive a CDF of y using these steps. You can see CDF of y is nothing but while probability of y less than or equal to small y, which can be rewritten as ax square, just replacing this one here, x square less than y, and so on. X square is less than or equal to y divided by a, and finally x is less than or equal to square root of y by a. So we can do it. I think you can easily follow it. So next what we get is that probability this can be rewritten as like this, because this is the you can see the absolute value. This is absolute value, so the value of x will be ranging from minus square root of y by a to plus square root of y by a. So finally because this is a range, we know the probability of for a range can be written in terms of CDF, right? So this is the highest range, this is the lowest range, so we can rewrite the expression like this. And now we can differentiate the CDF and we can get the PDF. So we just differentiate it, and we can use the formula for function. We have seen it a while ago. So you just consider this is u, then you can find the du dfxu by du, and then du by dy, etc. And we can derive the expression in this manner, and it will be like this. If you cannot follow or you cannot do the derivation by yourself, you can see the textbook. I don't think this is very difficult. You just have to recall how the differentiation works. So just practice some differentiation. So anyway, we are going to use this derived formula for the PDF of y. Given that, what will be given? We will be given fx, and we will derive the PDF for y. So in the expression of fx, we will replace the value of x with this value, square root of y by a. Similarly, we will replace the x with minus square root of y by a, etc. Now, if this was fy, but there is an exception. If fx is an even function, we can write like this: fx minus x is equal to fxx. So this is the property of even function. We know it is symmetric about y-axis. In that case, these two you can rewrite this, and if you rewrite this, these two will add up, and it will be look like this one. It will look like this one. So we are going to use this in our next example. So let's remember this formula, and let's see what is the example. So we are going to now find out a PDF of random variable y, capital Y, where it is given where y is defined as the function of random variable like ax square. It's a power function. And it is also said that given that x is a standard random variable. In chapter 4, a standard normal random variable, we have defined this random variable. It looked like a Gaussian shape, you know. So, and its formula is like this one. Here, what does standard mean? Standard means mean mu x is equal to 0 and sigma x square was equal to 1. That was the definition of a standard normal random variable. So when we put the value of sigma x and mu x, we get the function like this one. If you don't recall what is standard normal variable, I would suggest you pause the video here and go back to chapter 4 and have a look. So this is given. So in your question you might be given this formula or you might be given this statement. Anyway, we get this one for fx. Now, so this fx is a basically even function. It is symmetric about y-axis, and what we are going to find out is fy. So in finding fy, the fx we will follow this formula which is derived in our previous slides. So in using this formula, we have to use square root of y by a instead of in the place of x. So here we get x squared, you see here. So we will replace this x with this part and we will get this one. Obviously this 1 by 2 pi will appear here, and there is an additional factor ay that will add up here. So this is it. So now now we will jump to another topic, which is expectation of a function. When we are going to find the expectation or average value of a function, we will use these two formula. First one is for discrete and second is for continuous random variable. So what is the difference between this formula and the formula given in chapter 3? Basically, the difference is that in chapter 3 we use, instead of gx, we use just x into px or x into fx. Here we are keeping the probability the same. The probability of x remains here, but x is being replaced by gx. So that's how we are going to find the expected value of a function gx. I hope you are following. And obviously, because we are finding average value or expected value, so we have to consider all the possible values of x or all the possible range of x. Now, for a linear function, we can see how it looks like. Expected value of gx will be equal to expected value of ax plus b, because gx is equal to ax plus b. So the expectation operator will operate on x. It will not operate on constant b. So it will be like this: a into expected value of x plus b. In your textbook, this term is derived in another way. You can have a look. So when we are finding the variance, we know what is variance. Variance is expected value of x minus x bar whole square. So here this is x and this is expected value of x, and there is a whole square, and we can derive the variance like this. We can simply ax plus b. Now what we are going to do here is we distribute this expectation operator over ax and b, and then we get expected value of ax and this is just minus b, because this expectation operator will not operate on b. So we will have b, these two b cancel each other, and what we will find a into expected value of x, and we can take a common, and we will get something like this. And we can take this a out of the expectation operator. At first we can take common a square, and then we can take it out. A square can we are taking a square out of this expectation. So, and finally what we get here, x minus expectation of x, or x bar whole square, and this is nothing but sigma x square. So this is our derived expression for the variance of the function gx, where gx is nothing but ax plus b. So what we are getting finally, it is just a square into sigma x whole square. So here we have derived two things. First one is, what is the moment, first moment, or the expected value of a function gx, where gx is equal to x plus b, which is simply a into x bar plus b, and the variance of gx is nothing but a square into variance of x. So we are going to use these two formula in our example. For example, we are giving an example like this. Our midterm exam is out of 60 marks. So let's say the mean value or expected value is 45, and the variance is 100. That means standard deviation is 10. So if you are given this data, then you have to find the distribution, not the distribution actually, the mean of actual mark, which is like this: mid mark plus 1 grace. So here mid mark is actually, you have to consider this mid mark is half of the 60. Okay, so you know your midterm marks is converted from 60 to 30. So actual mark will be 60 divided by 2 plus 1. Here actually it should be divided by 2. So mid mark 60 divided by 2 plus 1. So that is your grace mark. So if this is the case, now what is the value of a? The value of a is 1 by 2, because we are dividing this 60 mark by 2 to convert it actual mark, and then we are giving some extra mark, which is b is equal to here 1. So a is equal to half, b is equal to 1. Then we can find out the distribution of actual mark, which will carry expected value equal to, according to this formula, and it will also carry a variance which is equal to this formula. Okay, so here in this formula a would be equal to half. So sigma x square, the new sigma x square will be sigma x square divided by what? Half a square into half a square, so that will be 1/4, that means 25. And the new mean will be equal to half into expected value of x, that is 45 plus 1. So I hope you can write it down on your paper.